For example 2, we are still with a particle undergoes a uniform circular motion. Okay, but this time the radius is given as 28.7 and the force on the particle has already been given with the magnitude. So, and what they ask for the kinetic energy. So we use K as a kinetic energy, okay? So we can start with the definition of the kinetic energy K as the half mv square, okay? And after that, I'll just have a play around with the equations, okay? So as we know that the force on the particle due to the magnetic field is F, okay, and is also the centripetal force, Fc, that making a circular motion, and Fc can be written down as mv square over r, okay? So then we see some kind of similarities between what Fc and what the terms of K is, okay? So that what I'll try is I will have to play with F by putting a half here. So if I times this equation by half, okay, so that I have half mv square, I also need to times it by 2, okay, so that will make 1. So it will be half mv squared times 2 over r, and half mv squared here is actually K, or kinetic energy, so that we have 2K over r. So that K, or kinetic energy, can be written in terms of half Fr, okay? And that we substitute what the question has given us, so with R and F. So we have F as 1.6 times 10 to the minus 17 Newton. And we have R as 28.7 micrometer. Micro is 10 to the minus 6 meter. Okay. So Newton and meter will give you the unit of the energy, joule. Okay. But if I want to write down the unit of energy as electron volt, because the energy for the electron is so small, so we use the electron volt unit instead. So I can divide this expression by 1.6 times 10 to the minus 19 joule per electron volt. So which is 1 electron volt is this number of joule. So that the joule unit can be cancelled with Newton meter. So I can have the kinetic energy in term of in the unit of electron volt. So 1.6 can be cancelled. And finally, what I get is 28.7. So times 10 to the minus 6 will become minus 4 when I try to times this the power 10 together. So I have 10 to the minus 4 electron volt. And that is the kinetic energy that we are looking for.